Hello all, today in this video I'm going to provide an email spam detection with simple RNN. With this previous data set, previously we have worked with different machine learning algorithms. From this the video we will be working with some deep learning algorithms. For that, initially we are importing the libraries which we are needed, and then we are loading the data set. So this data set we downloaded from Kaggle. You can just give us phishing email detection data set. Kaggle means you will get this data set. Then we are printing what are the entries in the data set. So you may notice that this data set is having nearly three entries, that is three columns like unnamed, email text and email type. And apart from that, we are also printing whether this um, values or columns is having any null ones. So if it is having any null ones means we are going to fill it. And after that we are also working with pre-processing. In pre-processing, within this work we are using the label encoder. For that we are using the label encoder function. And then before that, within the text we are calling the email text. And for the labels, which is the target variable, we are calling the email type. And then since email type is the y variable, we are displaying it in an graph where how many plots for safe email and phishing email is having. When compared to safe email, this phishing email is having only less number of entries. Now we are going to make use of train test split function to determine variables like xtrain, xtest, ytrain and ytest. By this we are using the text and labels which we have determined previously. Text serves as the x variable and label serves as the y variable. Then we are determining the test size as 0.2, that is 20% for testing and remaining 80% for training. So if you want to use some different test size also means you can just change over here. That is for example 30 70 means you have to just replace this test size as point 0 point 0.3. Then again we are making some pre-processing by use of the tokenizer with the xtrain, that is extra variables only. Then for that we are converting by using this tokenizer, we converting this xtrain and xtest to sequences. And also we are padding that sequences by using the pad sequences function. Then we are making use of the RNN neural network layer description. So this is what we have used for it. Here it is initially having the sequential layer, then it is having the embedding layer with the input dimension as 10,000, output dimension as 128, and the input length we have given as the max length. Then we are calling the simple RNN layer with units 64 and activation as tan h. Then we are using the dropout layer. Dropout is an optional only if it is used for overfitting. If you don't need means you can just leave it. Then we are using the dense layer. Here we have given the dense layer as 1 because this is a binary classification work. But if you are using some multi-class layer classifications means you have to replace this dense layer, that is 1, with the number of the classes you are having. For example, you are having 3 class classification means in this dense layer you have to replace 1 by 3. Then mostly for binary classification we will use the activation function as sigmoid only. Then we are compiling the model. For compiling, here we are using the Adam optimizer, and also we are giving an some learning rate, specifying the learning rate as 0.001. So it is no needed to specify, but if you are specifying means sometimes it will just boost our accuracy. So in the next code we shall work without specifying this learning rate. So you can also identify, and also we can also work with without using dropout function. So by checking with that you can just note the difference, what is the use of this dropout and the learning rate. Then we are using the loss as binary cross entropy and metrics as accuracy. Then we are fitting the model by using the padding sequences, extrain padding sequences, then y train. Then here we are training for 10 approaches. Batch size we are given as 64. Then the validation data we are using as X test pad and Y test. Then we are just training our model for 10 approaches. We have got the values of accuracy, loss, validation accuracy, and validation loss. So at the end, that is in the last approach, you may notice that accuracy is 7112, but validation accuracy is less than accuracy only. But for a better model, when compared to accuracy, validation accuracy should be only high. But it shows that this model is not providing better results. And as like that, a loss when compared to loss, validation loss is high only. Then we are displaying the plot by using this validation accuracy and validation loss. What I said that is when compared to validation accuracy, accuracy is high. So likewise the loss. So this is the code for this RNN, simple RNN with email publishing data set. In the next video, we will be working with some other criteria. Thank you.